Good morning, everyone. Welcome to another episode of Xar Talk Show. Today is 2019, November 23rd, Saturday, 5 o'clock p.m. San Francisco time. In sunny California, and we are going to do JavaScript plus SVG, scalable vector graphics, live coding plus tutorial. So I'm going to code it and teach in the same time, like explaining what is going on. So this is gonna be live script, and we are going to JavaScript, and we are going to do a real time creating a polyhedron, platonic solids, and rotate it in real time. Like this, we did this actually 2 days ago. So here you see a icosahedron, okay, and octahedron, and we're gonna write this from scratch. Now, last week we did one of these from scratch, so consider that as part one. You might go watch it, and today we're going to do it from scratch, so it's gonna be fast. And we're gonna create. Last time we didn't finish; we only created one face of the cube. Today it should be better because I did it once, and so we're gonna do a this. Then we are going to hold on a second. Let me check if I'm alive. My status. So I should be okay, right? Live. So 6 concurrent users, watchers. So yeah, I'm good. And so we gonna continue with this from scratch. We are going to do this, and we are going to. You see, there's a problem with this one because it's only doing wireframe. Wireframe is nice, but oftentimes we want opaque faces. So that means we're gonna do that today. Hopefully we can finish that in 1 hour, maybe more than 1 hour. So, but we need to start fast. We need to get going in order to do this. Now, before we begin, so today's talk show. So let me show you some JavaScript in depth. I need to mention this again. So this is my tutorial on complete tutorial on JavaScript. So you can learn from it. You don't need any. It's not using any framework. It's not using any library, which is what we are going to do today. No framework, no library, no React, no nothing, no, not even the, not even the, let's see, not even the jQuery. Okay, no libraries from scratch, pure JavaScript technology. And so I have my tutorial, and if you like, I'm going to refer to it many times because I use it for my own as a reference for my own coding. So I'm going to refer it many times, and you can just search for Xali JavaScript in depth, you'll find it. So it includes, for beginners, you just read this section, okay, JavaScript basics, that will get you started. But this tutorial, this project is actually in depth. It covers many things you will not see anywhere in any other JavaScript books, okay, especially the style, the treatment. Okay, anyway, that's, so you have JavaScript reference as well, object reference, then you have DOM. JavaScript and DOM are separate things. They are actually separate, entirely separate technologies. So you learn JavaScript, the language, then you learn DOM. DOM is what enables you to do these web applications, single page web applications. That's the jargon. So you need to learn DOM. So I have a beginner's tutorial on DOM here. Then you also have SVG technology. Now SVG is what allows you to draw graphics, circles, two-dimensional graphics. That's the technology we are going to use today. And as you can see, this is SVG. What you are seeing is SVG, this polyhedron, platonic solid, icosahedron. Okay, and we are going to begin that. But before we begin, let's take 1 minute to say hi to people. Hello, beautiful people, all you beautiful people here. Emily and hello, beautiful people, and Kathy and Matt and Zoomwelt from Florida, and you guys are from UK and Czech Republic, and Kathy from UK. So Zetro, hi Zetro. So let's begin. Okay. So today we're gonna focus on JavaScript. So if you know JavaScript, if that's your job, if I stuck somewhere, just post opinions. Post opinions. How you do it? How do you? Maybe I have an error. Tell me. So please do. That would be great. And if you don't know JavaScript, so if you have any questions, when I'm doing things, please do ask. Okay. So we're gonna do quickly get to first of all, we're gonna create this thing quickly. Repeat what we've done last week. Okay, so first thing, so let's begin. So far so good. Keep the comments coming. Okay, so far so good. So good. Good or no good. Okay, so JavaScript. Oh, maybe I shouldn't talk so fast in a rushed manner. We need to be relaxed and melodious. That's good. Okay, so here is so we are going to create a new page. Okay, so we are going to create poly. Okay, so we are going to create a new page. So let's do that. So we create a new buffer, save it as poly. Okay, poly2. Let's say .html. Okay, then we enter some template. Okay, hold on a second. So you can see this is a HTML page we just created. So show in browser, it's empty. Now let's add a title. So well, not title, but h1. So h1 live rotation of polyhedron. Okay, so show in browser, that's good. And we also need to change the title here and make that okay. Show in browser, live rotation of polyhedron, good. And we are going to now hold on a second, let me change my font so it's larger everywhere. So close that. Hold on a second, copy the path, close that, save it, put the path here, linkify, link it, show in browser. So the top one is what we have today. So before we do that, we are going to increase my font. So settings, I'm going to increase my Emacs font for all buffers, so I don't have to enlarge it every time. So that's how I do it. That's good. That's done. So put this here, adjust it a bit. So the fruit juice energy drink is doing its thing. Indeed, it is. My ritual of drinking energy drink. So we have that, and let me take a sip. A small sip won't hurt. Two sips. That's a gulp. Okay, now we are going to create a div element. Div. That's what we want, and we want to create an ID something. ID SVG. Okay, SVG EL. That's the SVG element. Show in browser. Okay, now we're gonna add a style at the top. Style. Now, if you don't know any of these HTML, remember I have complete tutorial on HTML, CSS, from the scratch, from beginners. So if you don't know, if you are not a web dev, check it out. And you can buy them for $30. It's the best book anywhere you can get for JavaScript, in my opinion. I consider there are possibly one or two other JavaScript book, either printed or online, that is possibly better than me, depending on which style of tutorial, writing style and you prefer. So I consider mine to be the top one in English language. So if you like it, support my work, buy it. Okay, the PayPal button at here, there. You can buy it. So, and okay, so back to the, so we are going to add a style. So hold on a second. Okay, so CSS, so this is CSS. We are going to add now, the ID, that's the JavaScript ID. Okay, then border solid thin gray. Okay, that's good. Close, save, reopen, show in browser. Now we have a border. Now it's empty, therefore you see a line. So now we go to, now we need to create a JavaScript. Now copy the file path, JavaScript, linkify. So here we created a link to a JavaScript. Open it, it doesn't exist. Create it, yes, okay. So here's our JavaScript file. So you can see console log 333, okay. Close it, save in browser, show in browser. Okay, it doesn't do nothing. We need to go to, because in Firefox I don't have JavaScript on, so we need to show in Chrome browser. So that's what so we are going to do that. So call the Emacs command. Xali open in Chrome browser. Okay, that's what we have. And now open the console log. Control command on the Mac, it's Command Option I. Okay, we can see the console log. You see 333. That's what we printed before. So that's all good. Now let's see my how okay, 11 minutes. Actually, we should go faster. Let's maybe skip the mundane talk and stuff. So how about talk about some advanced deep JavaScript features if you have time. We cannot do it today because if we do that, we don't have time to finish or even begin these polyhedrons. So we focus on how to do this today. So we have the JavaScript code is running. You can see there. And first of all, so what we need to do? So we need to create a SVG element. So like before, I'm going to show you how to create. To begin with, to do this polyhedron, I'm going to show you how you just rotate one face. Okay, so let's just write code fast and cube. Now if I'm going too fast, just ask questions. Or I had a video last week, just search my Xali YouTube, search for polyhedron. That is slower, and that talks about many things in detail. So right now I'm just going to do it fast to catch up. So create a constant cube face, and this is gonna be a array and array of values. So cube face, the corner, one face of a cube corner. So it's going to be let's say, so this is x, this is y, and z is coming out from the screen, x, y. So you want so focus on the x is 1, one face of a cube, so you need 4 corners. Okay, so we are going, then -1, then -1, 1. Okay, so that's the 4 coordinates, 3D coordinates of a cube. Now it's back, live streaming offline. Oh, okay, so apparently maybe I got YouTube problem. Live. Okay, so it's still good, so we're going to, okay, so we have a face of a cube, I mean the coordinates. Now we want to project. Okay, so we got a point in 3 space. We just want to project into a 2D plane. And the way we do that is parallel projection by simply dropping the z coordinate. So we're gonna write a project to plane. Okay, so that's a function, constant project to plane, and actually constant arrow function. So okay, so this function will take a 3D point xyz 3D coordinate and return just xy. You just drop the last one. Parallel project. Okay, so let's name it project 3D point to 2D. So now we need to, for each of the 3D point on the corner of the face, we need to project. So we need to apply parallel project to all the vertices of cube face. Okay, so cube face is an array. Then we can say map, then give a function, and we're gonna give that function. So the result of that is going to be cube points. Okay, cube 2D points. I'm not sure it's a good name, but let's just push on. Okay, so now we have cube. So let's show the result. Okay, so let's, when you code, it's usually nice to show the result. So refresh. So you can see we got the answer here. We got, you see, array, each element is just 2 points on the plane. So now we can start to draw that on, so to draw that, we begin to draw it. So to draw it, we need SVG technology. So SVG technology, you need to create, first of all, you need to create the SVG element. Create element, create new, I forgot what's the function name. Create element, I know what it is actually, create element. Okay, but for SVG we need create element and S. Okay, so it's not here, I don't have a brief for it. So let's go find out. So let's go to SVG. So SVG is, let me tell you what SVG is. SVG just looks like that. Okay, so this, for example, let's look at this one. This rectangle, to create this rectangle, these 3 lines of code is all you need. So you, first of all, you have the SVG tag width and height, then you close it here. Then you have a rectangle tag, and xy is the xy is a point where the rectangle begins, the upper left corner. Then you say width and height, that's the width and height of the rectangle. So if you put these 3 lines in a HTML file, it will show a rectangle. That's how SVG works. So SVG is basically XML, very similar to HTML. So what we are going to do is we are going to draw basically a rectangle, but instead of rectangle we need to draw a polygon, because when you rotate, a 3D object in 2D, it's gonna show like a polygon, like triangle. So this is what we need. So we need to create this in the HTML. So we need to somehow insert these 3 lines into HTML by using JavaScript. Okay, so let's do that. How do you do that? So how do you create this SVG and polygon tags inserted in HTML? So the way we do it is by, you go to SVG, and down here there is a scripting SVG example. So this is a full example. So you put this in a HTML page, and that will create, let's go to Brave. Okay, so because I have JavaScript, I don't have JavaScript on here, so hold on a second. So let's go to Chrome then. So you can see there is this graphics. entirely created by JavaScript. And how is that done? First of all, in your HTML page, you create this div tag. Then here is the JavaScript code that you create a SVG element. Then let's work on it. Let's just do that. Okay, let me grab the code, and we're gonna. So this is 3 minutes intro to SVG. So let me explain. I'm going to explain what's going on. Okay, so hold on a second. So, but ultimately, what we are doing is we want to basically create these 3 lines by JavaScript and insert it into the page. So, okay, so actually we don't need that. So copy it. So first of all, we create a SVG element. That's how you do it. Constant SVG1 equals to document create element ns. Then the second argument is SVG. That's just how you do it. That will create a SVG tag element. Then you set the attribute height and width of that thing. So let's say 600 by 400 width and height. Okay, so you will have basically a SVG element, a drawing area called, it's called viewport. Okay, then you start to create an element. In our case, we need to, you see here it's trying to create a circle. Now in our case, we need to create a polygon. So what is the element name? Polygon. So let's check SVG basics. So am I still doing good? Am I doing good? 9 people watching. I don't have any, well, usually I ask you guys about some questions, but I'm doing this so fast I don't have any questions. So far so good. All good so far, so great. So we are going to create a polygon element. So what is the name of polygon? The element name, okay, it's polygon. Okay, because you cannot be too sure, because sometimes it's poly. Okay, so poly, polygon. So this creates a polygon. So face, let's say face 1. Okay, that create a polygon. And what is the attributes for the polygon? So we can see the attribute for the polygon is, so you have points and then you have style. Okay, so attribute, so we need the attribute face 1 points, and here list of coordinates, list of numbers. That's what we need there. The others we don't need. Okay, so we need to do this list of numbers. So now we need to, you see this cube 2D point, that's our list of numbers. Actually that's an array. Remember, the cube 2D points, that's this array. So we need to turn that array into this format. Basically a sequence of numbers. So what we can do is that, the way to do that is that dot toString. I think it'll work. toString. Okay, and copy that, delete that, paste it here. So face dot set attribute points, then a list of numbers in a string form. Okay, I hope so far is so good. But actually, before we do that, let's see, we can actually print out console log, and let's see if this is the format we need. Okay, let's comment this out. We don't need that for now. So we are printing it out to see we got that's the format what we need. So refresh. Okay, that's good. Looks good. That's exactly the format we want. A bunch of, a sequence of numbers. So okay, so this is what we want. So we got a face. Now we're going to attach this face into the SVG here. Face 1. Then we need to attach the container to document. I mean the SVG. We need to attach the SVG1 to the div element. Wait, this is not what. Let me do it here. So okay, we need to attach our SVG element we created into the div element. So what is the div element name? Okay, so here we get it, open the file again, go to the top, let's say constant, okay, constant svgel equals to document get element by id. Okay, then paste the id. So now the svgel1, I mean the svgel is the div element. Okay, that's an annoying name. So div1, let's just name it div1. Okay, div box. Okay, let's say div box. So go back to the HTML, rename it div box. Okay, rename it div box. Okay, now open the open the JavaScript. So div box is the div element. We need that because we need to attach our SVG to it. So div box dot append child. Okay, then we append SVG1 to it. Okay, that should be it. Let's try it. Now we should see some graphics. No, we don't see the graphics because I know the problem. Because our viewport is 600 pixels by 400 pixels. However, our cube face is only between -1 and 1, so it's very tiny. You don't see it. That's a problem. So there is a solution of SVG. Oh my god, this is taking longer than I thought. Going through what we did last time, 1 hour, this to recreate the whole thing, the explanation is taking much longer than I thought. So the problem, you see, so the solution to do that is we go to SVG. There is called the thing called view box. So this is what you need to do. SVG width, height, those are pixels. Then you specify a view box, which basically means you can specify, you can tell the browser from the left to the right how many, is it how many virtual coordinate, how long it is. So in our case we have 600 pixels, but then we can tell the browser that is actually from, let's say, from -2 to 2, so it's actually 4. So that's how you do it. So we need to add this view box thing. Okay, so let's do it. Set width and height. Okay, then so this view box, so what we need to do is set view box and 4 numbers. Okay, 4 numbers will be the first 2 number means the coordinate for the upper left corner. So for us it will be -2 and 2. Okay, so -2 and 2, and the second 2 number is width and height. So width is 6 and 4. Let's just say, wait, let's make it square, so because square is easier to compute. So 600 by 600 pixels, and the width will be 4 and 4. Okay, let's go back to browser, refresh. It's empty again. It's empty. I know why, because our polygon does not have a color, like it doesn't have a feel like this thing, style, feel blue and stroke blue. So we need to create that. So let's do it. So the polygon, this is so tedious. This is so we are going to say face1 dot set attribute, and style will be okay. Style will be that. Back to browser, show it. Nothing. Why is that nothing? Feel. Okay, so feel stroke blue. Sometimes it's too small. That's why you don't see it. Feel yellow. -2. X and Y. So the upper left corner should be -2 and -2. This is important, because if you specify the wrong number for the view box, then your drawing is somewhere there, but your view box is showing here, so that's why you see nothing. So maybe this will fix it. There we have it. So we have a view box. Let me get the terminology correct. But hold on a second. So let me explain. Okay, let's go back to the HTML, and let's make this display table. Okay, so display table means make a shrink box. Now that's CSS detail. Ignore it if you don't understand. So now if we show it, you see this border is the actual SVG viewport area. So you have 400 pixels, 600 pixels by 600 pixels. Okay, so and okay, so let me show you so turn on the JavaScript console and go to the elements. You can see this part, this line is what we created. Can you magnify? Okay, magnify. Let's go. So you see this bunch of lines is what we created in JavaScript. So you can see SVG width and height 600, view box -2 and -2 and 4 4. So that means the upper left corner, that coordinate is considered -2 and -2, x and y. Okay, and meanwhile from the left to right is 4 unit, and top to bottom is 4 unit. So that's basically the user coordinate. That's how we specify it. Now our polygon, why is it not a square? I don't know. Let's now look at our polygon. Why is it not square? So let's look at Emacs problem. Okay, so our polygon, why is it not a square? Why is it showing a rectangle? So stroke blue. Oh, you need to specify stroke width. This is a very annoying thing in SVG. If you have a view box that is user coordinate, then every unit is with respect to the view box. It's not with respect to pixels. Okay, it's with respect to your view box. So you need a stroke width, something like that. So let's go to SVG. Let's see shape styles. So here is you need stroke width. Okay, so let's put it here. stroke blue and stroke width 0.2. Okay, fill yellow. Let's try it again. Show. Okay, so it is actually just showing a stroke. X, yeah, that is the reason. Okay, now we are not seeing a square because we are seeing actually the face we created is actually like that, like that. So we are looking at it edge on. So we can for example, if we change your face, then it will work. If we change the coordinate, let's see. Okay, show it. You see, now we are showing this face. Now we are going to rotate this thing. So let me check the comments. Live stream. Okay, so far so good. Okay, it's good facing. Okay, great. Welcome, Danielle. Hey Danielle. Danielle made more comments to stuff like keys. Anyways, let's keep going with the JavaScript. Uh, Hello, looks like some chill JavaScript today. Yes, we're gonna keep focusing on creating a live rotation of this polyhedron. We try to do that quickly. So how long I've been talking? Oh, 30 minutes. My God, this is so slow. This is going too slow. So okay, so let's push on. Any questions so far? Let me know. Okay, if anything unclear. So we keep using our old face, and next thing we are going to do rotate. Show some rotation first. So rotation, you need a code. You need a 3D matrix basically to do rotation. So last time I tried to explain how matrix rotation formula works, but today we're gonna skip it. And instead today we are just going to look at my existing code. Okay, just grab the rotation code, and we are not going to explain it. We did this before, so okay. So grab the code. That's what we're gonna do. Okay, so rotation code. Now we have the rotation code. Where do we put it? Put it here. Okay, so we have this function rotx that will, given a degree, it will rotate vertices. It will rotate a variable vertices. So the rotation is a bunch of math, cosine and sine formula. So you can see this code is easy to understand. So basically, what it does is that when you call rod x give a degree, then it will change this variable's value. This vertices variable is meant to be a list of 3D coordinates, just like our cube face. So let's change our cube face to vertices, or actually let's just change vertices to cube face. Okay, so find and replace vertices, replaced by cube face, replace. Okay, now let's rotate. Let's call rod x. Okay, so let's call rod x here, because we need to rotate it before we create the polygon. So rod x, and how many degrees? Let's say 30 degrees. Okay, let's say rod y, rotate with respect to y. Well, let's say rod z. Okay, let's get back to the browser. This refresh. What is the problem? Let's see, console log. Rod z, type error, assignment to constant variable. Line 38, assignment to constant variable. Okay, so line 38, rot z, assignment to constant variables. What assignment to constant variable? Cube face is a list of points in 3D. Okay, then we have rotation x, rotate y, and rotate z. Then it says, okay, so yeah, because we are trying to change cube face, but however we declared cube face to be a constant, so that's no good. It needs to be let. Okay, refresh. Okay, so why is it not rotated? I don't know. Let's see what's going on. So okay, so we need to rotate before, because we need to rotate it before we generate the 2D points. So we first rotate it, then project those 3D points into 2D coordinates. Then we create the polygon. So let's show it. That's good. Let's expect we success. So let's organize the code a little bit. So we need to put let's see, create SVG element. Then we create the polygon. So let's move these two down here. So we create a SVG element, then we rotate our vertices in 3D around Z, then we project it to the plane, drop one coordinate, then we create a polygon. That is correct order. Okay, now let's do a live rotation. Let's get this quickly. Let's go in. Live rotation. So you need an event to detect when user press keys. So the way you do that is you want the dev box, actually the body of the page, HTML page, then add event handler. Add event handler. Okay, you need the DOM function to add event. So what is the DOM function? So go to DOM, add remove class attribute, add remove event handler. So we have add event listener. Add event listener. Okay, so input, then you need a function. Key. Okay, so actually this is not key. This is not input. It should be key. Like when user press. Okay, when user presses up and down arrow, it should rotate the thing around the x-axis. Okay, that's what we want to do. So body add event listener key. Then what happens when you want to call a function when user presses a key? So we are going to cheat. Okay, so we are going to cheat by looking at the code we have. Okay, so we're gonna cheat because that will save us time. It'll save us a lot time. Okay, okay, so let's do that. So key press. Okay, so we are going to create a function here. Do key press. So do key press is a function. So if the key is okay, so if the key is arrow up, then we do rotate x, then 30. Okay, let's say 5 rotation increment. That's kind of 5 degrees. Every time you press a key, rotate 5 degrees. So if user press left and right, then you rotate around the y-axis 5 degrees, okay? Then we need to, so when user press the key, you call do key press. Okay, but then you need to render it. Okay, so we need to, right now it won't work because we already created the face. You see we rotated here, then we do, when we generate the 2D points, then we create a face. All these things must happen after the rotation. So we are going to create a render function, new function, okay, constant arrow function, render, and we're just going to grab those things inside the render function. Okay, and this render function will take no argument. Let's put the rotate there before. Okay, so render function. So rotate 30 degrees, then you need to call render. So we need to call it render function. So render function needs to be called. So we call it here and attach to the SVG container. Yes, we need to attach it. So move it into here. Render function. So we're gonna call render, and also over here you need to do key press, then you need to render it. So let's write the arrow function. So you call do key press, then you call render. Okay, every time you press a key, you call do key press, which rotate the thing, then you call render, which renders it. So let's try it. Render error, body is not defined. Okay, so body. So what is the body of HTML? So body is not defined. Yeah, okay, you need document.body. Refresh. Good. Let's try to press the keys. Up arrow. Nothing happens. Why is that? Anyone know? Up arrow. So up arrow, nothing happens and no error message. Let's try up arrow, down arrow, left arrow, right arrow. So debug time. So every time we do key press, let's print something so we know key pressed. Okay, refresh. Up arrow, it's not even called, it's not even being called. Okay, so something wrong with our event listener. So let's look at our code, my code somewhere else. Let's see, did I have it? Oh, you need to pass an argument to do key press. Of course, the event for key press. So this will be key. You need to pass the argument to do key press. That's right. Okay, let's try it again. Try up arrow. It's not being called. Do key press. Event key. Oh, let's look at the code again. Let's look at the key down. Yeah, so idiotic. So the reason it's not working because we are using the wrong event name. So the event name should be key down. See, the very annoying key down. Yeah, okay, thank you, Matt. So let's refresh. Now press up arrow. There it is. Fantastic. Now this is very interesting. You know why this happens? This happens because when we are rotating, so every time we press the key, it calls rotate, right? It calls rotate, then it calls render. It calls key press here, then it calls every time. So the key press does some rotation. Then we call render. But every time we render, let's go to the render code. Render here, it just creates a new SVG, the polygon element. Then you press a key, it renders again another polygon element. So it doesn't erase the old one. That's why. And by the way, mathematically, when you rotate something like that, this shape you see here, that is actually a hyperbola. Okay, uh, that's a little math stuff, math theorem. That is actually hyperbola. When you rotate a cube, do I have a cube? I don't have a cube. But let's say you have a dice. A dice. You spin it on a table. Then on the side you will see. Let me show you. Okay. You spin a dice. Then on the side you'll have a silhouette, and that is the silhouette is actually chocolate. I mean, not chocolate, but that silhouette is actually hyperbola. Okay, where is it? It's not showing up here. So we have polyhedron chocolate. That's what we're gonna do today. We are okay. So do I want to show it? I can find it in a minute. In one quickly. So this is well, that's math. Okay, we are not going to talk about that. But anyway, this is what you see. That is the shape exactly. What you see here. What you see here. That that. When you rotate a line, basically when you rotate a line, you rotate it like then it becomes a hyperbola. That's just a interesting thing. There it is. So you rotate a dice on table, you take a photo, and you'll have a silhouette, and those curves are hyperbola. Okay, that's just interesting thing. Now let's get this fixed. Every time we want to remove the old copy. So what did Zimwell? Things just got hyperbolic. Yes. So let's every time we create a new face, we want to erase existing face. So what we do is we okay, so we say erase existing. Okay, so svg1 dot inner html equals to empty string. That's one way to do it. So back to browser, refresh, press up arrow, fantastic. Press left arrow, fantastic. Now we got a face. Okay, now we got a face. Now let's do, actually we can take a break now. So the rest is easy. Now we are going to create, the rest is easy because all we need is the create more faces and different vertices for different polyhedron, like octahedron, or we can have cube. It's just a matter of adding more 3D points. Now it's interesting to, it's about for the cube, it's very easy because all the points are just, all the points are easy to find. So let's put this in the right shape. Let's see. Oh, this is actually, hold on. So you can see for the cube, or the corner, it's -1 or 1. It's also very simple if you are doing octahedron, because you can see all the wait, how do you do this? You see all the coordinates are just 1 and -1. Very easy to find. But it gets interesting if you want a isocahedron. Now, how do you find those vertices coordinates? You can go to Wikipedia. It's a bit tedious, okay? We are not going to go through it, but we are, I already have the coordinates, so we just put them in. So actually, that's great. So let me take half a minute break, and let's start to. So we actually caught up almost to the last time we did for 1 hour. 56 minutes. Okay, so far so good, guys. Okay, I'm dropping viewers like crazy. Now it's 6 people. So far so good. So let's continue. Let's continue to the interesting. Starting to get fancy. Bathroom break. Okay, bathroom break. Poly 3. Let's go to. Okay, so let me just grab the code I have. Okay, so I have several versions here. We want, in fact, we have a version here. Let me show you this version. Okay, Chrome, showing Chrome browser. You see, this is the goal, what we want to do. And you see, this version is already done. We can go wireframe. Now, there's a very interesting feature of this version. Now, can you guys see it? Oh, yeah, you can. There is a very interesting feature. You can see, let me stop rotating. Okay, you can see the lines crossing each other. You see, it shows when it's in front, it will cut over the lines behind it. So that's an interesting feature. So this is not just wireframe, it actually does something interesting. And you can say, you can also change patch style. Okay, let's try wireframe, and you can change orthogonal projection, perspective projection, and you can change. Oh, you cannot. Anyway, so that we are going to do this. So right now we are just going to grab a bunch of codes. Seafloat saw Alan Doc's theme. I think I saw in Discord you speak Spanish, Latin. Oh yeah, so okay. Uh, First person 3D engine. Okay. That's okay. So let's continue. Okay, so let me continue this, and we are going to. Here's what we gonna do. We're gonna first of all grab the full code. Okay, so actually, let me grab the full code. So now, right now, we only have one face of cube. We want all the coordinates of a cube. So let's do it. So what we're gonna do is going to create constant vertices. Okay, actually, I don't want to show that. So constant vertices. Okay, actually, so this is actually taking much longer. I'm starting to feel actually like I need a break. So let's do this. So we are going to create a bunch of vertices for the cube instead of just one face. Okay, so So actually, so let's just put a global variable here, 10. Okay, so we're going to create a object, and hold on a second. Yeah, we're gonna create a object. This object is going to have Emacs bug. Save, open. So this object is going to have a cube thing, okay, and its value is another object, and that object will have vertices, okay, a bunch of data, then faces. Okay, so vertices is the vertices of a cube. The faces will be the index to the vertices of the cube. Okay, and let's grab that. You will see how it is done in a minute. So actually, so it is going to be this, right? Okay, so wait. So we got a cube data. So not vertices, poly data. Okay, and here constant vertices. Okay, we don't know what they are yet. So the poly data will contain the object cube. So we can select, cube or icosahedron or others. But let's do cube first. We are racing against time. Alice says. The Red Queen says to Alice, if you don't move, you are falling behind. So we need to race to it. So poly data. So what am I doing? So poly data, we are creating a database of all the vertices of platonic solids. Okay, so and cube is done like this, very symmetric. That's the vertices of the cube. And v is 10. V has the value of 10. And now, and the faces are just indexed to the vertices. So one of the face is 0, 1, 2, 3. That means the first vertex connected to the second vertex to the third one and fourth one. So that's how we generate the vertices. That's the data structure for our cube. Okay, so now we got that poly data. Now once we have poly data, we don't need the cube face anymore. The cube face will be defined in terms of poly data. So we will say cube face will equals to poly data. Then okay, cube wait, that's so our cube face is actually just one face. Okay, so this is getting more and more complicated. So poly data dot cube is this object, right? And we want to get one face. So then it will be dot, actually let's use this notation. Okay, cube then dot faces. Okay, then you get the first face. Okay, so 0, we use index 0. That will be the first face. Then for each of this index we need to actually get the coordinates. So that means dot map a function. So the function, arrow function, takes a index I, and we need to get the, oh god, this is much more code than I expected. So polydata cube dot vertices, okay, then I, okay, that's the code. Let me show you here. Okay, so basically that's the code. So this line should actually recreate that, so let's print it. Console log, okay, cube face 2. Let's just see if we got it correct. Cube face 2. Undefined, undefined. It's all undefined. That means we screwed up somewhere. Of course, the code still works, but however, the way we try to grab the cube face, the new data structure, is not working. This is so complicated. So cube 2 face. So we get poly data, then cube, then faces. Let's just print that, okay? Let's see what we get. So faces 0. So this line should return 0, 1, 2, 3. Let's see it. Yeah, it's correct. So blind coding is actually working, but not yet, not fully. Okay, so now you got the indexes. You need to map. You got these indexes. Then you need to get the vertices. So index polydata dot cube dot vertices. For each index is one vertex. Oh yeah, so you didn't return it. That's why you need to say return. Okay, you see what I'm saying? You need to say return when you use arrow function like that. But actually, a better way to do it is to just simply remove the curly bracket. So this is good. This is no good. So delete that, make it into one line, and you don't need return anymore. Show it. We need to print. So print it. Show it. Yes, indeed. Successful. Look how beautiful it is. A bad man, so like would be proud. So actually we are not going fast enough. All these hours we just got this stupid thing. We need to see a thing. We need to see this solid, man. And you guys need to go to sleep. Because it's late in UK and Germany. I'm not sure many people are still here. Emily, Emily and Kathy, are you guys still here? Oh, you abandoned? Okay, so we didn't. It's a lot of work. JavaScript without libraries, of course. So now we got okay. Now we got a full face. Okay, now we see we can see how this is actually working now. We don't need the original face anymore. So back to the browser. Where here? Refresh. Yeah, now it's God. Oh yeah, because we changed it to 10. Oh, now it's like whoosh whoosh. Oh, okay, where can we see it? Oh my God. No, it's too big because the vertices is 1. Vertices should be 1. Okay, or we adjust the view box. Remember this view box, let's say 40 and 40. Okay, back to browser, show it. Okay, now it's kind of, yeah, okay. So and now we need to adjust the coordinate at the top left corner. So let's say 2020. Redraw. Now it's good. But we need to do all the faces. So let's do it quickly. Let's come on. So let's get one face. So we need code to get one face. So this just get one face. We need to get we need to do this for multiple faces. So let's see, cube face. Cube face map rotate x. We need a lot. There's a lot of things to do. I mean, it's in principle it's very simple. You just need to add more faces, but you need to do this in a systematic way. So when we rotate x, we need to rotate all the faces, not just one. But how do you you see, we got this one face here. So you need to rotate all faces. Emily says at face to sleep. I'm like a lot of faces. Okay. Tetsumi, where are you from? Back to sleep. Okay, so what I'm getting distracted. I need to get this finished, and in fact I need to go to the bathroom too. It's too much drink. Live streaming. 1 hour and 12 minutes. Okay, so let's concentrate and let's get this going. This big apple juice. Okay, guys, let's see. Big apple juice, the giant megaton. Let's okay, so we have one cube face, and when we generate the face, the SVG code here, it creates SVG element. Then we don't need this rotate anymore. Then it render. When render is called, it it projects the three-dimensional points to cube faces. We need okay, I know what to do. So let's go back. Okay, I know what to do now. Well, I don't know. I don't know what to do. Well, I know what to do, but not yet. You need to concentrate when you do these things. Okay, so this render function, it cube face is a nested array where each element is a 3D coordinate, a point in 3D. You project it to the plane. So cube face is just one face. You need to do this for multiple cube faces. Cube has 1, 2, 3, 4, 5, 6 faces. So you need to do this for 6 faces. So you need to create not just one polygon. You need to create 6 polygons. You see this polygon element SVG. So let's change face 1 to, well, let's not rename them, because when you do rename it gets confusing. So where are we? So you can see the element we generate, this is the code. So there's only one single polygon. Now we need to actually generate 1, 2, 3, 4, 5, 6 polygon SVG elements. Okay, so we need to generate 6 polygon SVG elements. So this is just one of them. But how do you, I mean, the right now the problem is not how to do it, but like we have to figure out the data structure we are using vertices. So cube has one two, so 1 2 3 4 5 6 7 8, 1 2 3 4 5 6. Oh yeah, those are vertices. So face you have 1 2 3 4 5 6, six faces, 8 vertices for a cube. Okay, so vertices. So actually, let me cheat a little bit. Okay, let me look at my old code. Nested array of 3D coordinates. No, that's not just nested coordinate. And you dot value dot vertices. I'm stuck because if I go ahead and do what I think I'm going to do, which will work, we will create a cube. However, we will not be able to quickly do the isocahedron and the octahedron and others, because if I just go ahead and do what I'm thinking right now, then my code, the data structure will be incompatible with what I've already written. That's the thing. So I can quickly do it now, but then we start to do isocahedron, then we'll have a problem because because I can no longer simply copy and paste the existing code to help we move along. So that is why I have to think about what is my code is actually doing, so we can follow it that way. Uh, okay, so actually this indicates a documentation problem, because normally when you have things like this, you should be able to just read, just read off what these vertices are. But here it is incorrect, because all it says is vertices is just a nested array of 3D coordinates. So that doesn't make sense, because if you have a polygon, if you have, yeah. So I think it's actually nested, like two level nesting. Okay, I'm getting, this is getting bad. We are stuck here, and we haven't we need to get the whole thing in place, because otherwise today's video is just like last week, no difference. No difference. Vertices, God, I need to get this poly data. So what are the comments? Convert to TypeScript and write a more general interface next screen. Well, yeah, that's a lot of work, and also when you do TypeScript, then a lot of people don't understand it. uh, oh yeah, and also Alan, created live rotation with the mouse, which I haven't actually had time to grab that code. To, yeah, I haven't been working on this. This all these new features is, by the way, by a professor. He did it. He's yeah. So anyway, I let's I need to get on with this. So at least today we have some polyhedron to look at. So let me just think about this to get this right. Okay, so by the way, Alan's code, you guys can see Alan's code. Then 1998 day, because Alan's code. Where is your Alan's code? I don't have it handy. Um, so Alan, post it or something. If you can post to YouTube. So okay, so let me focus on this. So vertices, polyhedron dot value dot vertices. So it actually give you vertices. Okay, so vertices is a okay. I don't like this structure actually. Vertices is just a complete list of vertices. Okay, I know what it is now. So vertices is just a complete list of vertices. Okay, so I know what is going on. So let's go back to our cube. So polydata vertices is just a complete set of vertices, and it depends on the faces to tell you, which vertices connect to which to create a face. Yeah, so vertices is just a rather randomly ordered list of 3D points. So once you have vertices, so it is the face that matters. Okay, it is the face that matters. Okay, so when you rotate, you actually just rotate all the vertices. So it is the face that matters. Okay, so face, can we put it down below? Let's try it. Okay, okay, it's working. And go back to, okay, so now I know what the faces are. Vertices. Okay, so now I need to okay, so cube face. So now we're gonna do something. Okay, so we're gonna do this. So we are going to change the cube face and into vertices. Okay, and this is gonna be, so cube face, the structure of cube face will be changed. So it's no longer like that. So instead, the cube face will be all faces. So in fact, I mean all the vertices. Right now it's just, so cube face will be actually cube vertices. That's what I mean. So you have more than 4 points. So that is what the vertices will be. So let's remove cube face. Let's remove it, comment out. So vertices will be the list of all vertices for the cube. So we can do that by, let's use this syntax. Okay. So it's not 0 anymore. Wait, so you get polyhedra, you get cube, then you get there's so much work we need to do, so much work. Okay, I know what to do. So here is what that that's simple cube. That's that polyhedra cube, not faces, just vertices. Okay, that gets you the vertices. Now faces, let's define faces. Let faces equals to, the face will be a nested array. Each element will be one face. Okay, this is getting very complicated to get this going. Faces, value dot faces. Okay, face index. So face index. So polyhedra cube and faces. Okay, so vertices and face. So you got the vertices and you got face index, and we need actual face of a cube. Okay, let's just copy the code because we are running late. So get face is a I think this is no I don't think I'm doing good. This is stuck for too long. Join the chat. Jeff Bezos, I think his code is on GitHub. Yeah, but yeah, so you can, you can go to, well, Alan's code is on GitHub. I don't know if I this well, if I don't finish this, it's kind of a failure because okay, let me just do it. We must finish this. At least we must have a polyhedron up there. So face index gives you the index of faces. Then get face. I don't like the way this is written currently because it's not, it's not really um, how to describe. Anyway, so get face one of the face. Okay, get face ith face indexes. Okay, so that's the face indexes. Let's just follow the code. Okay, face indexes. So you get one face, then you map and get vertices. So okay, so get face returns one face. So now we can say cube face. Here's how we back to the original. Let cube face equals to get face. Let's say the second face of a cube. Okay. Okay, that's how we get cube face. Okay, just like before. However, though all this data is changed, they need to be changed to vertices. Change that, change that, change that, change that, change that, change that. Okay, and one more. So cube face, this line of code generate a data like that. That's just one face. Okay, and so you need to get face, and where is the part where we generate the SVG element? So create a polygon. So we're gonna create more than one here. So create a polygon constant. So you need to project the points. So instead of a cube face, you're gonna project all the vertices of the object into 2D plane. And here you start to create one face, cube face. So you're gonna start by, so we have the faces, face indexes. So we start with the indexes of the face. Then we, for each of the face, we're gonna call a function, arrow function. Okay, for each index of the cube face, so this is one index of a face, we're gonna create a SVG element for that. Okay, so for each index of a face, that's that. Okay, so let's call these indexes face indexes. What we're gonna do is, so for each one of these, we're going to get face. Okay, map function I, so the ith face, so face index is I, get face I. So get face returns the actual coordinates for the faces indexes. So that, so here we is a bunch of vertices. Then we, that's right, so we create a SVG here, and we need to get face 1. So we create, for each face we create a SVG. Then we, the points will be, we're gonna finish this soon. Okay, it's almost done. So the point will be, you see here is when you need to concentrate, because this is rather getting quite advanced. So if you haven't paid attention, I don't know, you don't know what I'm doing, I don't even know what I'm doing. I have to really just focus on this, get 2D points. So here it is. So yeah, that's what I think. Okay, so I think we have it here. I think it's too much code here to, so here is, we are creating a polygon for each of the cube's face. So we begin with, we create a face element, polygon element there. So let's rename this face 1 to poly G. Okay, so we create a polygon element, and we add the attribute, not that. Okay, we add the attribute. The second element is the, basically a string of numbers. So how do we get the string of numbers? So remember, we are creating a polygon. So we, each vertex is needs to be a two-dimensional point. So what we do is we, what? So what we do is we get the face. So we get the face. What? So face indexes. So we get the face. Oh god, this is going bad. So we get the face, the vertices of the face, then one of the face. You see I here. Then we map for each one point in that face, vertex 3D point in that face, we parallel project to the plane, so it becomes 2D point. Then we just to string, it becomes a string. I think that should work. I hope there's no errors. So polygon set attribute, then we create if this works, please, then that is almost done. We are almost done. One more minute. Refresh, please. Oh, fantastic. Okay, there's some minor issues. You see this? We can fix that because you see it's weird here because at least we got something after 90 minutes. Now it's easy to add isocahedron and all the other fancy ones. Now we got this problem because right now we don't know which one is in front, which one is behind. We can fix that, okay? We can fix that. But so what do we do now? So first of all, let's fix this annoying thing. So instead of fill yellow, let's say fill none. So it doesn't actually do that. Okay, so now we rotate. Okay, that's good. Now let's just add the isocahedron. Okay, the code isocahedron. It's just a bunch of data points. So we're gonna grab this whole thing. Okay, so we're gonna grab this whole code. I'm gonna show you what that is. Okay, copy it, close it. I'm gonna show it here. So in fact, I'm going to show it like that. Okay, so I'm gonna compact the code so you can see. So we have dodecahedron, icosahedron. These are platonic solids. You see. So you see we have a init vertices. So this function will take one argument, and this argument will be a polyhedron name, such as tetrahedron, cube, octahedron, and so on. Okay, and it will wait. I did something wrong here. Okay, so yeah, so you can see this structure. So this function will basically, all this function do is it will just fill the variable vertices and face indexes. That's all it does. So we're gonna copy this code, cut it, and use in our code. So now instead of this polyhedra, we just define the function here, define it, okay, and we just say init vertices polyhedra we don't need that. Okay, poly data. So where is our poly data? So what? Oh yeah, poly data. So we don't need poly data anymore. We delete poly data and we delete vertices here. We delete our constant. We delete cube face. So then we move the variables to the top. So vertices is a list of vertices, 3D points, and face indexes are the index to the vertices, to how they connect into faces. So we have init vertices. that will just initialize it. So we do it by let's say default is cube. Okay, so we need to call init vertices. Okay, that just fill the two vertex variables. I hope that will work, because this is getting more and more, well, it's reasonably getting, yeah, 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 money, money. Now let's replace cube by isocahedron. Okay, let's do dodecahedron. Replace cube by dodecahedron. Yes, 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 yes. Ah, good, good. I can call it a day now. I can, this is good. How long have I been talking? 1 hour and 40 minutes. I think I should stop. Wireframe view, solid view. Oh, okay, should we do solid view? It will take 5 to 10 minutes. It may take 10 minutes because when you actually code, lots of things come up. So we begin. I mean, we did from scratch this, and now we have this. Okay, then we can create the menu. Should we do it? Are you guys interested? Okay, let me ask you guys. Should we go on to show how do you actually create solid face? So instead of wireframe, solid face. So that's choice one. Or we continue to create the menu, so you can select, you can select what polyhedron to show, like cube, icosahedron. Which one should it be? Or should it be good for today? Yeah, because today is already too long, so we might can be done for today. What is that? UFO? Dodecahedron. Dodecahedron. Oh, dodecahedron. Right, we have that. So call it a day. Okay, or call it a day. Finish up the menu super quick. Okay, so let's do menu. Yeah, so okay, so let's do menu. Okay, yeah, so let's finish menu. So finish menu. this this is help me cheating. We gonna this is, I intended to do actually the solid and actually more stuff, but it really takes a lot of time to get them. So okay, so what we need to do is just add a menu. So add menu, you go to my DOM tutorial, then you go to what menu should we want? Pop-up menu. Yeah, okay, pop-up menu. So you select this code. That's what you need. Select this code. I'm gonna show you what they mean, what they do. Okay, so you go back here, you open the HTML file. What are those? You open the HTML file, you paste it here. Okay, so here is the code for the menu. Okay, so you say select ID, select polyhedron, select solids. Okay, then you give a ID name, send name, size 1. Size 1 means you can only select one at a time. So then you say actually, should we use menu or radio box? I think I prefer radio box. Okay, well, let's stick with menu. Okay, so anyway, so you select, so that's what you do, and value 1 is cube. Okay, cube. Then value 2 is octahedron. So I need to spell it correctly, so I don't remember how I spell it. So here are the names. So tetrahedron comes first, then cube, then octahedron. Okay, then icosahedron. I always got it confused. Sometimes I say isocahedron, but it's icosahedron, not isocahedron. Okay, we got a menu. We got a menu. Now next is the JavaScript code. We don't need this. Okay, the next part is in the JavaScript code. You need to add. So here is a menu. So you go to the browser, show in browser. We got a menu at the bottom. Let's select cube. It doesn't do anything because we don't have JavaScript event. So let's open the event. So open the JavaScript here. Then we need to add a event. So first of all, so how do you event? So let's paste the code. Let's see. So first of all, you need select solids. Okay, create that, select solids. Okay, cut that, go to the top, paste it. We put on top so that we know all the requirement from the HTML. So we are selecting this menu, and that element is called select solids. Okay, then we need to know which item is currently selected, and you do that by select solid dot value. Then you get you get one of the string: tetrahedron, cube, octahedron, icosahedron. Are we missing one? We are missing octahedron. Oh yeah, no, we are missing dodecahedron. Okay, yeah, so okay, we got that. Then to find out what's the current selection, all you need is this line. So we don't need the rest of here. All you need is that line. So now we expand, go to the initialization. We, instead of saying that, we type that. So that is actually the proper value. Okay, let's make it work. Tetrahedron, that's correct, because in HTML by default we have tetrahedron selected. Okay, so now you can rotate, and now you can select cube. Well, cube. Okay, wait, that's not cube. Okay, so we getting, the menu is covered by video screen. Okay, yeah, I thought so. I'm finding it too late. Okay, but let's fix it. Oh, my video is big. It's yeah, no, it's okay. When we select octahedron, it's not working. Let's select dodecahedron. Oh, it's not working because we don't have event listener yet. So we add a event listener for our menu. So select solids, go to the bottom, select solid dot add event listener. So listen to input, yes. So when the menu is changed, we call a function. Let's just say change solid, okay. Call a function. Okay, so when we say change solid, so change solid needs to be a function. So constant arrow function, change solid, and takes no arguments, and the result will be the result will be okay, so we need this, hold on a second. So the result will be, we need to call init vertices and give it a name. So that will fill the variables vertices and face indexes. So make it one line. So init vertices change solids dot value. Okay. Okay, so that is the function, but actually when user change the menu, you also need to render it. So we actually need to call change solids, and we also need to call render. Okay. Yeah. So let's hope. So refresh, move arrow key, change to cube, that's good. Rotate, that's good. Change to octahedron. Oops, cannot read property vertices of undefined. So did I spell it wrong? Let's go to the, oh yeah, I spelled it wrong. Octahedron, not octohedron. Refresh, select octahedron, good. Let's try to rotate it, that's good. Select dodecahedron, rotate it, good. And we are doing unit testing. Select as icosahedron, that's good. Okay, that's it for today. The menu is covered. Okay, so thank you guys for watching. That's too long, 2 hours. Very slow progress. So tomorrow, I mean next time we're gonna just, next time we do this, we are going to ask people to watch the part 1, something like that. Okay, thank you guys. Bye. I'm gonna shut down in 30 seconds. 30 seconds. 1 minute. That's 30 seconds something. So here is the HTML, and okay. So here's HTML. You can just search my website, Xali Polyhedron. You might on GitHub. There's. But anyway, the my code on GitHub is changing all the time. So, and also Alan has a copy. You search for Alan's website. Hey Kathy, you are still here. Kathy is a loyal watcher. So thank you guys. Yeah. So if you want to code, go to, just you can probably find it. Or go to the Discord, my Discord. Ask. You got the link. If you like my stuff, buy my JavaScript tutorial. Okay, JavaScript, SVG, and all that. It's all good. Thank you guys. Bye.